Yeah, hello. I just realized the previous screen was a bit cropped. So, yeah, this is the full working. It's a bit blur, but yeah, I can take a look at it. Just pause the video if you have to. And yeah, that's about it. Now let's move on. Okay, so now we are going to focus on radians, okay? So, radians, think of radians as it's just another unit for degree, okay? So like you know how for height you have meters and feet, so radians is also another unit for angle, okay? So you have degrees and radians. So your whole life you have been using degrees. Now we're looking at radians also. So it's a new concept to you, just try to grasp as much as you can. So just note that for 180 degrees is actually equals to pi, okay? So 360 degrees is actually equals to 2 pi. So when you're trying to calculate your length of the arc, uh, so the initially the formula was theta over 2 pi, sorry, theta over 360 times 2 pi r, right? So your 360 sub in with 2 pi, so it will cancel off and then you will get your length of your arc is actually equals to r theta. Okay, so that's the formula. And then for your area, similarly, sub in the 360 with 2 pi, and then you get that the area is actually equals to half r square theta. Okay, so do note that you only use this formula when your angle is in radians. And if your angle is in degrees, you use this formula. Okay, so know when to use which. And also, if you see your calculator, right, has two settings. One is degrees, one is radians. So make sure that you're on the correct setting when calculating the according one. So when you're calculating for radians, make sure that your calculator is also in radians. So yeah, for exams, my advice is, if possible, get a second calculator or borrow from your senior or something, and then uh have one calculator in radians, one in degrees, or you can just switch. Like really depends, up to you. Okay. Okay. Anyways, let's look at some questions now. So yeah. Um. Okay. So the question is asking you to find, show that, sorry, we have been through this already. Okay, yeah. Let's look at this question. Uh, the question gives you that AOB is equals to 5 pi over 6 radians, and you're told to find the length of major arc. See, they gave you the angle for minor arc, but they're asking you to find the length of major arc. Okay, so your first step is to find this angle, theta 1. So theta 1 is basically equals to 2 pi over 2 pi minus 5 pi over 6. So this gives 7 pi over 6. Okay, so your length is basically equals to r theta, so 8 times 7 pi over 6. Okay, and in the case where you don't remember the formula r theta, you can use the same formula, the previous one, which is your angle, so 7 pi over 6 over, so instead of 360, so this where, remember previously it was theta over 360, so this is your theta, this one sub with 2 pi, and then times 2 pi r is the same formula, just sub the 360 with 2 pi, and then you will get the same thing. Okay, this is only if you don't remember this formula. I highly recommend you go and memorize this formula, because yeah, it's quite simple. Okay, the next area of your sector. So okay, so let's take a look at this question. You're told to find angle AOB in radians. So you're given that the perimeter is 23 cm. So that means you can find the arc length. So wait, where's my part one? Yeah, sorry. This part one. Okay. So your arc AB is basically 23 minus 8 times 2, which is equals to 7 cm. So 7 is equals to r theta, and r is given to be 8. Therefore, theta is equals to 7 over 8. So this is your angle in radians. Then your next part, they ask you to find the area of sector OAB. So just plug in the formula. A is equals to half r squared theta. Your r is equals to 8 square and then theta is equals to 708. So your final answer is 28. Also remember the units cm square. Okay, yeah, that marks the basics. Also, I want you to be comfortable with converting from radians to degrees and vice versa. So let's do some practice. I will show some examples. So if I want to convert pi pi over 12 radians to degrees, just change the pi to 180. So yeah, then you get 180 over 12, which is equals to 15 degrees. So alternatively, if I give you 2.8 radians and I want you to find the degrees version of it, you can also do that. So remember earlier, 1 pi is actually equals to 180 degrees. Therefore, 1 radians is actually equals to 180 over pi. Okay? So 2.8 radians is basically equals to 2.8 times 180 over pi. And then this would be your final answer. Okay? So similarly for degrees to radians, just divide it by 180 and multiply by pi, since yeah, pi radians is equals to 180 degrees. Yeah, you just need to manipulate the formula. So similarly for 315, it's just 315 over 180 times pi. Okay? So I want you to do these questions. Try it out, and then if you're facing any difficulties, do PME. Yeah, so similarly you have this as well. Okay? That's about it. Yeah, I will pause for now, and then the last part I will do just two questions and do a quick summary of this chapter.